In this video, we'll be covering systems of equations, specifically the method of solving them using substitution. This first example is relatively basic. You'll notice that one of the equations is already y equals in terms of a linear equation. The second equation there is not in the form of y equals. If you wanted to, you could get it into the form of y equals 2, but since we're going to be using the method of substitution, really all we have to do is make sure that one of the equations is solved for one of the variables. It doesn't have to be y, but it can be y if that's the one you choose to solve for. In this case, because it's already solved for y, I'm going to just take this entirety of the equation and I'm going to substitute it into this equation specifically for that value of y. So when I do that, when I take this whole equation and plug it in for y, I'm going to end up with negative 2x minus 3. I'm replacing the y, so I'm going to put parentheses around everything that I put in there. And up here in the first equation, y is equal to 6x minus 11. So this is what I'm actually going to have in terms of the equation that will solve this system. Again, this method is called substitution because you're specifically substituting in one of the variables from the first equation into the second. Now again, you could solve the second equation for y or x and substitute that into the first. Both of those methods are valid and they're perfectly fine to utilize. In this case, I'm just going to simply solve utilizing the most simplistic method that I can identify. So the next step we have here is simply solving this like it's a linear equation because again, there's only single power of x. I'll make sure that I distribute this negative 3, so I'm going to have negative 2x minus 18x plus 33 equals to a negative 7. I'll combine like terms, giving me a negative 20x. I'll subtract the 33 from both sides. So I'm going to have, sorry, let me put that there, equals to a negative 40, and therefore if I divide both sides by a negative 20, I will end up with a x equals to 2. So this is the start of the solution to this entirety problem. Again, remember, with the systems of equations, we're looking at two separate equations. So in theory, we're looking at two linear equations. This one crossing at negative 11 somewhere down here with a positive slope going like this. The second one here, if I were to solve that for y equals, I'd add the 2x and divide by a negative 3, giving me a negative something, and therefore something along the lines of probably like this. 1, 2, so somewhere about here. So those are the two linear equations that this system represents. The solution is actually the intersection of those 2 points. So what you're really trying to do is you're trying to identify where do these two graphs intersect. Now, again, the way we have to do this is we first solve for either x or y by substituting one equation into the other, and then we take that x equals 2 and we plug it back in. Now, we plug it back into the first one because it's easier, so I end up with y is equal to 6 times 2 minus 11, which is really y equals to, in this case, 1 when I'm all solved and done. So I graphed this relatively incorrectly. This should have been steeper, and the point should have been somewhere up here, but the point is that I have the solution of 2 comma 1. This seems like a valid solution. You can verify the solution by taking x equals 2 and plugging it into the second equation. If you don't get y equals 1 back, then this is not the correct solution and we've made a mistake somewhere in the problem. So when I plug in 2 for x, I'm going to get negative 4 here. Negative 4 adding to both sides is going to give me negative 3 on this side. Divided by negative 3 gives me y equals to 1. So sure enough, that is checked as being the correct answer. So again, this is the method of using substitution. Let's go ahead and look at one more example. The second example we're going to look at is the set of equations negative 3x plus 3y equals to 4, and the second equation is going to be negative x plus y equals to 3. So in this particular set of equations, we're going to do the exact same thing, but this time nothing's solved for y equals already. So we're going to have to solve for y equals. Now we could solve this first equation for y equals, but in my mind, and I'm taking these steps ahead of time, I'm going to add the 3x over and then I'm going to divide by 3. Dividing the positive 3x by 3 on that side will give me back a nice even number, but dividing the 4 by 3 will not. So I really don't want to solve this equation for y equals if I don't have to. The same rule goes for x. I could solve this one right here quite easily for y equals. So that's what I'm going to do. I'm going to go ahead and put an arrow here. This equation is the same as y equals if I add x to both sides, x plus 3. So now this secondary equation is going to be the equation that I'm substituting into the first equation, simply because, again, this is an easier thing to solve for. Now, could I have solved for x instead? Sure, but I think it's going to be more steps if that's the case. So I'm going to take this thing and I'll plug it into this one up here. So now my equation is going to read negative 3x plus 3 times parentheses. My y is now x plus 3 equals to 4. Making sure that every time you substitute that stuff in, you put parentheses around that so that you can distribute things accurately. So I get negative 3x plus 3x plus 9 equals to 4. Awkwardly enough, the negative 3x and the positive 3x cancel each other out, and you're left with 9 equals to 4. but 9 doesn't equal to 4. So at this moment, you're gonna make the inclination that this doesn't make any sense, that maybe we've done something wrong. Nothing's been dealt with wrong. This is a situation where these two lines don't actually intersect. Okay, when you get to something that doesn't make any sense, 9 equals to 4, 3 equals to 7, negative 1 equals to pi, none of those things are actually true. If this isn't true, then this particular system has no solution. Now, I would recommend that you verify this by trying to get y equals and showing that both of these linear equations do actually have the same slope. If you can prove that they have the same slope, then you can prove without a doubt that then they don't intersect, and therefore there will not be a solution to the systems of equations. This is how you solve equations using substitution. Again, the mentality is here that you're solving one of the equations for y equals or x equals, you're plugging that into the second equation, and then you're making sure that when you're done with the problem, you write it in coordinate point notation, because that is, again, a solution to a system. It's not just x equals, it's x comma y, or in some cases x comma y comma z.